instructor. Hello, my friends, and welcome to this very exciting new practical activity on convolutional neural networks. If you're not too overwhelmed by the previous section on artificial neural networks, well, then you will smash with me this new section. Because basically, a convolutional neural network, as you saw in the intuition lectures, simply consists of adding an extra layer, which is the convolutional layer that, as you understood, gives eyes to the AI to the deep learning model. Because indeed, with a convolutional neural network, we can now take an image or a 3D frame as an input, as opposed to our previous artificial neural network, which could only take an input vector containing some features as information, right? Remember the features of the customers in the back. But here we're going to add at the front a convolutional layer which will be able to visualize or see images just like humans do. So that's pretty exciting. We're making a step further towards human intelligence because the fascination that scientists have about deep learning is that it's the branch of machine learning that gets artificial intelligence closer and closer to human intelligence. And you will even see in some more advanced courses on deep learning that not only weaken eyes to the AI, but also some memory with the LSTM cells, but also some critic sense. Well, there are a lot of innovations in the deep learning science, which is absolutely fascinating. But here we're going to focus on CNNs. And so there you go, my friends. Let's start this new practical activity. And as usual, before we go into this folder, let's make sure everyone here is on the same page. I gave you the link to this folder right before this tutorial in the article. And so now please follow me into part 8, Deep Learning, where inside we're now going to go to convolutional neural networks. All right, so for this section, exceptionally, we only have an implementation in Python. And that's for the simple reason that R is more used for data mining, kind of machine learning, or advanced statistics, high dimensional statistics. But I have not met any scientist in my life who does computer vision with R. There are some libraries like Deepwater that can build a CNN for computer vision. But really, the best and most advanced programming language for deep learning is definitely Python, thanks to the amazing libraries that have been developed by Google and Facebook. Google developed TensorFlow, which is an amazing library for deep learning. And Facebook developed PyTorch, which is another amazing deep learning library. But these two, TensorFlow and PyTorch, are only used with Python. And that's why, exceptionally for this section, there will not be an R implementation of the CNN, right? The ANN was fine because we were still doing some advanced data mining with neural networks. But for computer vision, really, your best option is Python. All right, so let's go into Python. And now, second different thing compared to before. As you notice, you will only find the implementation here in this folder and not the dataset. That's for a very good reason. That's because the dataset is actually super huge in terms of size. It's a couple hundreds of megabytes because the dataset contains lots and lots of images of cats and dogs. We're going to see them in a second, but since it contains a lot of images, well, I did not include the dataset here. Otherwise, for those of you who want to download the whole machine learning dataset codes and datasets folder, well, it will take a lot more time if I included this dataset here than if I left it separately, which is what I did. I left it separately and I gave it to you actually right before this tutorial in the same article. So I hope you downloaded it because right now we're going to have a look, right? At the bottom of the article, right before this tutorial, you had to download this exact folder. Well, actually the zip folder, but I already unzipped it. But you had to download this folder, Section 40 Convolutional Neural Networks, which indeed contains not only the codes in IPYNB format and PY format, but mostly the dataset. The dataset, which contains 3 subfolders. The first one containing all the images of cats and dogs, but for the training set. Which means that we're going to train our CNN model on all these images of cats and dogs in the training set. And then we have this other folder, which is a test set, on which we will actually evaluate our model with new images of cats and dogs on which the model wasn't trained. And finally, we have this little folder here, which only contains 2 images. And this will be just to test the model in production with a single image. So we will first take this image of this beautiful dog to test that our CNN can detect the dog, can predict that indeed we have a dog in this image. And we will do the same with that image of a cat so that we can check that indeed our CNN predicts that there is a cat in this image. So as you understood, I just explained the problem actually. We're going to build and train a convolutional neural network to recognize if there is a dog or a cat in an image. Okay? So I hope you like the case study. Of course, this time it's not a business case study, but we're going to have a lot of fun doing this, and it's a great way to be introduced to convolutional neural networks. And even if it's just an introduction, you will see that the CNN we're going to build will be quite advanced. And actually, the implementation is quite advanced with lots of technical tools, which will, of course, perfectly do the job at the end. Okay, so that was the second specific thing. The data set was given to you separately. All right? And just to show you quickly the training set and the test set. So in the training set, you have lots and lots of images of cats and dogs. Actually, you have 4,000 images of cats and 4,000 images of dogs, right? I can take anyone. This is a dog, another dog, many different breeds of dogs. So if you love dogs, you're going to have a great time looking at the images here, right? And there we go. This is a very cute dog, by the way. Okay, and same for the cats. You have many images of cats, right? Of different style, different colors. So whether you're a cat lover or dog lover, you will have great time looking at any of these images. And same for the test set. Well, you have 1,000 images of cats here and same 1,000 images of dogs. So just to recap, in the training set, you have in total 8,000 images, with 4,000 images of cats and 4,000 images of dogs. And in the test set, you have in total 2,000 images, with 1,000 images of cats and 1,000 images of dogs, right? It's important to keep the numbers in mind because we're going to use them in the implementation. Okay, good. So make sure to have this on your machine because of course we will use it to run our code. And now, third specific thing that I wanted to highlight in this first introductory tutorial. It is the fact that for the very first time, we won't be able to run our implementation, which is this one convolutional neural network, that IPYN-B. We won't be able to run this implementation on Google Colab. Why is that? That's for the simple reason that the dataset is too big for a Google Colab notebook. And therefore, for the very first time in this course, I will show you how to run this implementation on Jupyter Notebook. Because with Jupyter Notebook, we will be able to access directly from our machine the dataset. And we will run the code from our machine. But within a Jupyter Notebook, okay? So what we'll do, in fact, in this new section is we will still re-implement this whole code from scratch on Google Colab, but at the end, once all this is implemented, we will simply go to File here and then click here Download. IPNB, and this will download the IPNB file, which we'll be able to run on Jupyter Notebook. All right, so that's what will happen, but we will stay on Google Colab to implement this together. And speaking of which, well, right now we have to save a copy in Drive because this is in read-only mode, and therefore we need to create a copy to be able to modify and re-implement the whole code. All right, so let's do this. As usual, let's delete all the code cells, right? Only the code cells. Make sure to keep the text cells to keep that well-highlighted structure because indeed now we have a pretty long implementation. So it's important to keep the structure so that we can take a step back anytime and know where we are going. All right, so let's remove only the code cells and now reaching part 3. You're going to recognize some of the same steps as before with the ANN, right? This is part 4 and there we go. All right, so that's the whole structure. Let's have a look at it from here. So at first we will import the libraries, then we have a structure in 4 parts. Part 1, date preprocessing. Part 2, building the CNN. Part 3, training the CNN. And Part 4, making a single prediction. So it's exactly the same as before with the ANN, and only this time in Part 1 we'll do a different work, because for the very first time actually in the course, we won't be pre-processing a classic data set. But this time we'll be pre-processing some images. and therefore the data pre-processing phase will be different. It'll consist of doing two steps. First, we will pre-process the training set, and then we will pre-process the test set, all right? Then in part two, we'll build a CNN, the whole architecture of the convolutional neural network. We will initialize the CNN as a sequence of layers. Then we will proceed to step 1, convolution to add to convolutional layers. Then we will proceed to step 2, pulling, more specifically max pulling. Then we will add a second convolutional layer to make it a deep neural network as opposed to a shallow neural network. Then we'll proceed to step 3, flattening, to flatten the results of all the convolutions and pullings into one-dimensional vector, which will become the input of a fully connected neural network. And finally, we will connect to all this the final output layer. Then in part 3, when training the CNN, well, same as the ANN, we will first compile the CNN, and then we will train the CNN on the training set while evaluating it on the test set. We will clearly see that in the output. And finally, we will make a single prediction to test our model in production. And so we will deploy our CNN on two different images. One that will have a dog, and the other that will have a cat. And we will hope that our CNN can recognize respectively the dog and the cat. All right, so that's our structure. I hope you're ready for it. And actually, I'm sure you are. So if that's the case, well, join me in the next tutorial to smash this implementation. And until then, enjoy machine learning.